Hi everyone. Welcome to our webinar, Unleashing the Future, Building Intelligent Autonomous Agents. I am Anjali, and on the behalf of Walking Tree Technologies, I am thrilled to have you all here today. We have got an exciting session planned where we'll dive into how intelligent autonomous agents can revolutionize business operations using cutting-edge AI technologies. Before we get started, let's take a moment to welcome those who are just joining us. For those who are new to Walking Tree Technologies, a big warm welcome. We are a company that thrives on innovation, focusing on providing solutions that leverage AI, open source frameworks, and other groundbreaking technologies. Our mission is to empower businesses by delivering advanced tech solutions that drive efficiency, scalability, and innovation. Today's session is all about autonomous agents. AI systems that can perform tasks independently, learn from data, and make decisions, unlocking incredible value for your businesses. We'll explore how these agents are not just a futuristic concept, but a reality that can transform enterprise operations in profound ways. We want this webinar to be as interactive and engaging as possible. Feel free to ask questions in the Q&A section at any time. And if something stands out to you or you have any thoughts to share, the chat feature is always open. What's one use case in your organization where you would see intelligent autonomous agents make an impact? Feel free to share your thoughts in the chat and let's get started. Without further ado, let me introduce our fantastic speakers for today's session. First up, we are honored to have Scott Siebold, the Chief Technology Officer at Walking Tree Technologies. He has over 30 years of experience in enterprise computing and cloud architecture. He specializes in designing and implementing cutting-edge technological solutions, including cloud-based architecture and autonomous agent technologies. Scott's expertise in applying AI-driven innovations and his passion for new technologies make him an ideal expert to lead discussion on building intelligent autonomous agents. Next up, we have Abhilasha Sinha, the solutions architect, and she also leads a generative AI division at Walking Tree Technologies. With over an experience of 20 years across multiple tech sectors, specializing in AI/ML, she has deep expertise in LLMs and enterprise development. Her leadership drives innovative AI solutions that optimize workflows and enhance business growth. Today's goal is to help you understand how autonomous agents can enhance your expertise in enterprise operations through practical examples and insightful discussions. Scott and Abhilasha will show you how these agents can boost efficiency, improve decision-making, and streamline complex tasks. By the end of this session, we hope you'll leave with actionable insights and strategies to bring these technologies into your own organizations. Without further ado, let's get started. Scott, the virtual stage is yours.
Hey, thank you. Thank you very much. So let's just kind of get started with looking at, what is the market out there? What's it look like for autonomous agents and, what's going to be the growth? And if we look at a study from back in 2022, the global market autonomous agents and autonomous AI in general was valued at around $3.9 billion. Now, what's really kind of crazy is the growth rate is expected to be somewhere around 43%. That would mean by like 2030, that's about a $71 billion industry. So, and another report values it even higher in 2023, which is about 4.8 billion. And then, somewhere in the neighborhood of 65 billion by 2030. So suffice it to say, we can take away that, autonomous agents are going to continue to grow. So it's not just a futuristic concept anymore, but it's a reality now. And what we're going to do today is it kind of sets the stage for what autonomous agents are, and then we'll kind of go in depth into some of the frameworks that are used, and kind of the tech stacks that are used, and then give you a small demo as well of the agent ecosystem. All right, so let's just start out with, what are AI agents? Okay, so AI agents are really fundamentally, they're autonomous software entities. And unlike traditional systems, they operate based on predefined, that operate really, that traditional systems operate on, predefined rules. AI agents are designed to perceive their environment. They process the information they gather, and then they can take actions to achieve specific goals. So let's break the components down a bit. So first of all, when we talk about perceiving their environment, agents use sensors or inputs, whether it's data from APIs, real-time updates, or user interaction, and they use those things to understand their surroundings. And then they process that information. So once all that input is gathered, the agents analyze it, whether it's to identify trends or make sense of raw numbers or understand text input. So they process that input, then they can take actions to achieve some specific goal. So based on their analysis, these agents can make decisions and then execute actions without needing constant human intervention. So when we look at agents, let's just talk about agents versus traditional systems. First of all, how are AI agents different from the traditional systems? And I would say the key factors that distinguish them are kind of at a high level broken down into three factors, really. First of all, independence. So traditional systems, they follow strict predefined rules. In contrast, the AI agents have the ability to make decisions on their own, like we discussed briefly just a minute ago. And that's based on data they receive. So let's use a kind of a crude example that I can think of here. If you've ever used a Roomba vacuum cleaner, and we use one in our home, but that Roomba vacuum cleaner operates independently. It navigates a space, it adjusts its path based on obstacles, and autonomously returns back to its charging dock, most of the time anyway. And if it doesn't, there's probably something that impeded it for some reason. So I suspect even that kind of technology will just continue to grow as well. So the second factor in comparing AI agents to traditional systems is adaptability. And this one, to me, it's one of the key or core strengths of AI agents. They don't just allow the same set of instructions, or don't just follow the same set of instructions repeatedly. They actually learn from experience, and they adjust their behavior over time. And I'll take AlphaGo as an example. AlphaGo is from DeepMind, and it became better at playing the game of Go by learning from millions of simulations and adjusting its strategies with each game it played. And then the third factor is real-time decision making. AI agents can optimize their performance based on real-time feedback, and think of autonomous cars, for example. So autonomous cars, they adjust their driving patterns based on live traffic data or weather conditions, and the ability to make real-time decisions allows agents to achieve really more precise outcomes compared to traditional systems that rely on static rules. Now, the third aspect I'd like to look at in realizing what AI agents are is the multi-agent systems. And this is really a unique feature of AI agents. And so this concept of multi-agent systems, it means that these multi-agents can collaborate on different tasks to achieve a broader goal. And here's kind of how that works. So if we look at specialized agents, instead of relying on one agent to do everything, multiple agents can specialize in tasks. So for example, let's take something like supply chain management. One agent might be able to handle the inventory forecasting, while the other focuses on optimizing delivery routes. Another aspect of the multi-agent systems is efficiency and precision. So each agent performs its assigned tasks with high efficiency. For instance, let's take the logistics sector. One agent could predict inventory needs and be very accurate in that, while the other focuses on, cutting delivery times. And then kind of the last aspect in terms of multi-agent systems is the scalability and flexibility. And the beauty of multi-agent systems is that the beauty in terms of scalability and flexibility, that is that they can easily integrate more agents as new tasks arise. So as you get more tasks, you can just add more agents into the ecosystems or ecosystem. So let's take, for example, as your business grows, you can deploy additional agents to handle customer service queries, for example. You can automate accounting processes, or you can even manage, warehouse stock, for instance. So that's kind of a very broad, I would say, view of what an AI agent is. And I think the next topic let's talk about is, well, what types of agents are sitting out there? And Abhilasha, I'm going to let you take a shot at this one. I can add to it as needed, but I take this one.
Yeah, sure, Scott. Would you share your screen or you want me to share? Because
I can share.
Yeah.
That's fine. Oh, I'm not sharing?
Yeah.
Okay. Okay. I thought I was sharing. My bad. Okay. So Abhilasha, I thought I was sharing. So let me try again. Okay, can you see that now, Abhilasha?
Yeah, I can see.
Okay, good.
Yeah, so basically, the types of AI agents here is like the progression of complexity of the use case. Basically, if you can say broadly, that's how the types have slowly evolved. So if we talk about simple reflex agent, it is more of agent which works on like a specific task by task basis, where you maybe conditionally give a rule-based uh, behavior definition to the agent, and there's not much of like real proactive or autonomous intelligent there. But as we move on, like the model-based reflex agent is where we bring in a specific model inside the ecosystem of the agent, where it brings in that decision-making capability. And that's like the first or the basic version. As you add more complexity, so then you move on to the goal-based agent, where you're actually adding a goal to your agent behavior, and there is some there is some specific course of action that the agent needs to take to achieve the goal. Now, that could be like just if you talk about, say, drones or self-driving cars, which are autonomous examples of autonomous agents. Now, taking goal-based agents to the next level, where you bring in the value factor. So there it becomes the utility-based agents, where they are actually adding the value proposition to the decision what they are making. So they are able to decide and provide recommendations on what value, like maybe a product recommendation or a stock recommendation. Further on, like if the agent has the capability to further learn on its past recommendations, improve based on user feedback or based on the actual behaviors or maybe the market inputs. So depending on the use case. And finally, the last one, the multi-agent system, is more like how we take up a big complex task and break down into smaller specific tasks, where each agent is actually performing a specific task and doing it so well and then they together collaborate to perform the task. So that's how like we can explain these different types of agents, which can be like, so depending on the use case we are actually catering to, we can pick the specific type of agent we would need. So yeah, moving on.
Okay. So yeah, thanks, Abhilasha. So kind of moving on, the question that we should always ask with technology, really, and no different here, is, do you really need an agent? And, what I would say is I've tried to break that down pretty simply here and just kind of three basic things. So does your application, does it follow a cyclical process where it constantly adjusts its actions based on incoming data? If so, an AI agent is a great fit here. And then the other question is, well, does your application require adaptive decision making? So, the ability to adjust dynamically based on past actions or feedback, for example. Traditional systems struggle with this, but an AI agent really excels at this. And then finally, when we look at your system complexity, so complex state space, like a broad range of possible actions or paths, if it has any of those. If the answer is yes, it is complex, it's got lots of possible actions and paths, then the answer is really yes, because these agents are really good at that, right? So an AI agent really provides the flexibility and adaptability you need to navigate such a complexity, right? And that also, depending on the complexity, kind of helps you determine what type of agent, just like Abhilasha just talked about. Okay, so let's just look at this, and I'll cover this at a high level, and then I'll let Abhilasha really kind of dig into it a little more deeply. But looking at the AI agent at a high level, first of all, the AI agent itself, let's take a look at there in the center, right? So, and these high level elements, I'll say first is these form the foundation of the agent. So this diagram that you're looking at, it really outlines how the various components interact to create really a seamless, capable, a system that's capable of processing tasks. It can execute code, it can generate outputs autonomously. And then if we look in the center, that's where we have our AI agent itself. That AI agent is responsible for processing the inputs. It's got to understand the tasks, and then it's got to generate the execution steps. So the key to this functionality is the natural language processing, right? So the agent uses NLP, or natural language processing, to interpret user queries or data, and then it breaks them down into actionable tasks. And then then it executes those tasks based on the information it receives. So, and now as we look at the diagram, if you look up in the top left at the any data or document, one of the main inputs for the agent, AI agent, can be really any document or any data or document. And this could be structured from a database, or it could be unstructured data like text documents, PDFs, etc. Or it could be a real-time data stream, for example. The agent queries these documents to extract the relevant information. And an example of this would be if a user asks the agent to summarize the contents of a legal document, for example, or retrieve information from a data set. The AI agent first processes this input to understand what it needs to extract. And this is really particularly useful in scenarios like financial forecasting or legal document analysis, for example, really where the agent needs to work with complex and diverse data sets. Then if we look at the top right, the code executor, is really another critical component. And what it does, it takes that generated AI agent, or takes the tasks that are generated by the AI agent, and it converts them into actual executable code. Now, what that does, that allows the agent to go beyond just simple data retrieval or analysis, and it can actually perform tasks that involve things like running scripts or interacting with external systems. For example, let's say that an agent is tasked with automating a report generation process. It'll use the code executor to run the necessary code and then compile the report and then send it back to the user in whatever form that needs to be, right? Either on the screen or it needs to send an email or a notification of some sort. And it's really the ability to execute code in real time makes AI agents really highly versatile. And that allows them to not only gather the information, but it can also act on it. So whether it's updating a database, for example, or it's triggering actions, or even deploying updates to other systems. Then if we look at the lower right hand quadrant in the model response, any machine learning model, APIs, or other tools, for example, let's look at that. And that when we integrate into machine learning models or APIs or these external tools, this is when the AI agent really demonstrates its flexibility, because it can interact with forecasting models, prediction tools, chatbots, and really depending on what the task is at hand, right? It can interact with different tools and different APIs, different models. Let's take something like I'd use an example in like the retail environment, for example. So the agent might query a demand forecasting model to predict the inventory it needs for the next quarter. So in other scenarios, it might call an external API to retrieve weather data so that you adjust the travel itinerary based on that forecast. So we just had a huge event in the Southeast here, where I'm located in the Atlanta area, right? So North Carolina and certain Florida last night. So having based on those kind of things, we could even call some weather data API to say, hey, stay away from these areas. Obviously, we've got the news to do that, but even for small things, right? You could call an API to say, hey, don't go that route. There's a thunderstorm in the area, or certain other conditions, flooding, et cetera. So, what's really powerful here is that the agent has the ability to interface with specialized models, tools, and it can perform complex tasks. So running those forecasts, generating predictions, or pulling real-time data from the APIs. And as we look at the lower left, any LLM, any large language model in the bottom left there, the AI agent can leverage those LLMs, like those developed maybe from an OpenAI, like the GPT models, or the Meta or Google. And these models add an additional layer of intelligence. And that allows the agent to handle a more nuanced query, for example, and it can generate more sophisticated responses. An example of that, I would say, is using an agent to generate a detailed summary for market trends. And we're also going to look at a demo on doing stock analysis as well. Abhilasha will take you through that. But let's take the example of a detailed summary for market trends. That agent can query the LLM to analyze the financial reports, or maybe it's news articles, or even social media data for that matter. And that LLM provides a contextual understanding of these inputs. So that enables the agent to give more accurate and insightful responses. Okay, so to summarize there, by tapping into the LLMs, the AI agent has the ability to understand complex language inputs and respond with contextually relevant answers. And to kind of wrap up this slide, as we look at the user interaction, and an important thing in this ecosystem is that we have some ability, right, to have a human in the loop. So it's important. I mean, I would say highly important element is to have the human in the loop. And that provides really critical safeguards in many AI systems. That agent can perform tasks autonomously. And there are scenarios, though, where human oversight is extremely valuable or even flat out necessary. And that could come up in cases where you're dealing with financial context or legal context, for example, where it's really important that the information must be 100% accurate, right? So it might be a good time to put human in the loop there. And this paradigm allows you to do that. So just to, again, summarize, all this makes the system really robust and even secure, right? So that ensures that the AI agent operates independently. Humans can intervene in critical moments and ensure, accuracy and compliance. So Abhilasha, I'm going to turn this one over to you. How about you want to go through just a few of these, the open source agents?
Yeah, Scott. So just just as Scott mentioned, so the different aspects of the autonomous agent, which are required to for the agent to work as a whole and provide the intelligence autonomously. Now, there are a lot of these open source agent frameworks. You must have heard of most of them, like the more popular ones like LangGraph. AutoGen is one of the oldest, started with Microsoft, and then you have Creo AI, Llama agents, which Llama Index has come up recently, comparatively recently of all. And then there are others like Agent Light, which is from Salesforce. So each of these, at the pace, they have those key elements, what we just now saw. And they provide the ecosystem to have that behavior where you can interact with the model, you can perform the tasks, you can embed different tools, and let the workflow make decisions and perform the task. Now, but there is a slight difference in how it is implemented, and that's where some of these become more suitable for a specific use case. Like, for example, LangGraph provides a more structured and controlled flow wherein you actually depict the workflow in the form of a graph, and you associate nodes as the sub agents which perform different tasks, and then you have different tools associated with it. You can define conditional flows, loops, parallel flows. So all that capability is there. So these are suitable for scenarios where you actually need to have more control, and it's like a more complex decision flow which you want to model. But AutoGen, on the other hand, it is much more flexible and provides a fluid conversation like a group chat where multiple agents interact and perform a certain task. So in some cases, that may be what we are looking for rather than bringing in more control. Creo AI is another agent which actually is built on top of AutoGen to start with. And there again, we define the agents with roles and what tasks they're supposed to perform, associate the tools. So if you hear or pay attention, basically the terms are, so you will have a corresponding term for each of these frameworks, which will depict the workflow, which will depict the tasks and the tools. Now, how it is implemented, that's the difference. Most recent one, Llama Agent, so there it is like a more, you can say it is an async first design where each agent is like a microservice. The way they have structured it, it actually offers more flexibility and scalability, and leads to a more, again, it can be controlled, and you can have control on the flow of how the agent behavior is moving. So depending on the use case, one over the other framework would be useful. And also sometimes what happens is, I see in some of the cases, people would prefer to not use any of these and go ahead and define a custom one for themselves if they want to have a very low level control. But then based on whatever we have tried, these frameworks do provide a base to start with, and many of the aspects of what you would want to manage in an agent ecosystem, like the tools, tasks, the memory, the state. So that gives you a framework to start work with. And in some ways it is useful, but then it comes with its challenges where sometimes, since all these frameworks are evolving, there are some version issues. So it's because the entire technology is evolving and people are trying to do better and add more features. So sometimes we face those dependency issues and like things like that. But then overall, this is a good place to start with. So now, if we can move on to the next slide, Scott.
Sure thing.
So with so many frameworks for choice, when if you have to make a decision like for a enterprise grade autonomous agent, which framework to pick? So that also becomes like a important choice, because the kind of control you want or the kind of workflow you want, one framework may be suitable compared to the other. Apart from that, there are some factors which the framework does not provide on its own, and that is something additionally which would be needed in a typical enterprise environment. Like, for example, role-based access and authentication to your data and the agents. Then some way or mechanism to evaluate and compare the performance of your models and your agents. Being able to apply guardrails and ensure that the overall ecosystem is performing in a responsible way. Then being able to measure the performance in the form of some defined performance metrics, being able to monitor the results. So these are some basic things you would need for to be able to take your autonomous agent to production. So that's where we have, like at Working Tree, we have developed like a holistic framework where we have factored all these components as building blocks, which are like put together and combined with the open source frameworks like LangGraph, Crave AI. So at the base, we still have those popular frameworks, but as a whole, providing a overall ecosystem to ensure that you have the base and you have all the requisite components to build an enterprise-ready autonomous agent. So in today's webinar, we'll just give you a peek of that. So we'll move on to the architecture, Scott. Before that, just to talk about the different key parts or key pillars of the autonomous AI agent architecture. And this is the same thing which we have covered in the agent tree architecture as well, where you have the different components and how they are important in the behavior or the working of your agent. So if you start with perception and pre-processing, so this is how the agent senses or takes in data, and then how would you pre-process the data to ensure that it is as per your requirement, there is no toxic or biased data, and if there is any need for access control, role-based access. So all that is applied in this perception and pre-processing. Then moving on, the next aspect is the decision-making and action module. So that is where the brain of your agent is. Now here you would define your tasks, your different prompts of how you are interacting with the models, or what are the tools you need. So all that now in the prompts, what is the prompt engineering mechanism, like whether it is a react, reason, act, or maybe you want to apply a chain of thoughts. So depending on what is applicable, how you would want your agent to think and act, you would apply that here. Then if you need to build a learning agent which actually improves and holds the memory long term and improves its accuracy and behavior over time, so that's where the learning engine comes into play. Where we have the capability to take feedback, improve on the performance. Then the fourth aspect is the interaction. So this is the other important aspect where you're actually managing the communication of your agent or the multiple agents in your ecosystem. So it is both agent to agent interaction as well as agent to human interaction. So how would you want the human in the loop? And human in the loop is a very important aspect, again, as Scott showed in the earlier architecture, where human could be responsible for reviewing and ensuring your agent has given a proper result before sharing it with the outside world, the actual end user. So you could define your human in the loop in different ways. It embeds into your flow. Like, for example, if I talk about LangGraph, you have two different ways, like interrupt and authorize. So it's like if you want to stop the flow there and maybe give a new input because you're totally not satisfied with the current output and you want to do the entire thing all over again, or maybe you just want to give some feedback and let the system improve, or you're all good and you just want to approve. So these are the different possible ways how you can allow the human to interact with your agent and ensure that there is a level of control and predictability in your agent output. So that's where the interaction comes in. Now, the fifth aspect, the knowledge base, is where your agent is getting the wisdom, the context. That would be your enterprise specific data. And again, that's an important aspect to augment the LLM knowledge and ensure that you're giving the required context to your agent architecture, and your agent is able to access maybe your relational database, your vector store, whatever is applicable in your enterprise use case, and use it to provide the response. And finally, the evaluation unit. So in any generative AI application, you would need this to ensure that your agent is performing. So it's like a first level self-assessment, and you define some certain performance indicators which will give you like a numeric assessment of how your agent has performed and ensure that it is like meeting certain guidelines. So that again can be defined based on your enterprise needs. Moving on, the next slide is the agent tree architecture, which I earlier mentioned. So the these two slides go hand in hand. So it's more of a pictorial representation where you can see the preprocessors on the top left of the inner box, and then where you can have the different aspects of responsible AI, the guardrails, authorization, those kind of things. Then on the top, you have the knowledge store, which is your context, which you would provide to the agent. Then within the agent ecosystem, you have a single or multi-agent. You would have the task defined, the flow defined, the different tools, and each task could be associated with a model, or it could be at the agent level, however you would want to. So there may be like specialized models you would want to attach to a specific task. So we give that level of configuration, like flexibility, so that you can control and let the overall ecosystem work in tandem and give you the expected results. Finally, on the bottom left, you have the performance measurement block where you have the metrics, you have the evaluator, you have the feedback handler, and the overall observability, where we use like tools like Agent Ops and LangFuse. So there are multiple tools which are available. So depending on the framework of choice, the corresponding tool is used. And then overall, we deploy this on a cloud of your choice, or it could be on-premise as well, if you have the required infrastructure, so that we ensure that the security and privacy of the entire ecosystem is maintained. And that's where like you can use models like the APIs, or you could go with your own hosted models, the open source models. So you can actually like configure and use as per the need of your enterprise. So with this, this was just to give you an idea, and we will be planning a follow-up webinar dedicated on agent tree. So if you are interested, like just leave your comments after this webinar. for your specific use case, as earlier Anjali had also put up the question. So do share your views also, so that we can plan our next webinar accordingly. So yeah, Scott, maybe we can move on to the next slide. So yeah, before we jump on to the demo, we will quickly see the best practices when we are actually defining or designing a agentic ecosystem. We need to follow like a very structured approach to ensure that we are able to take it to production in a very predictable way. And that's where we have defined these different phases, where the first phase is more like developing a comprehensive process guide where you actually associate. So basically, whatever flow of your enterprise you're trying to replace or augment, I would say, with agentic workflow, you could associate a domain expert there and actually understand from the domain expert's perspective what are the steps, what is the workflow we are trying to replicate, so that we have like a very detailed visualization of the steps, the tools needed. Also, we should be very explicit, like if there's any implicit behavior also which the domain expert may be performing, we document it very explicitly so that we factor in it either in our model instructions or maybe an extra tool to be added, so that it is very, very clear and there are no surprises left. Also, that's where the first phase becomes very important. Moving on. So next, when we go on to the actual implementation, so we have to ensure like the architecture is well defined. We have identified which are the different agents which will perform. So basically, if you are going with a multi-agent ecosystem, right? So we would need to identify what are the agents we would need, what is each agent's task, what are the tools we would need. So basically, after we identified the workflow, then we are actually going on to defining the agent architecture by identifying the different aspects of it. Moving on. Then, of course, selecting the appropriate model. And why this is important? Because there are equally good models available now. And depending on the need of your enterprise, like whether to go with a closed model or you would want your own on-prem deployed controlled model, you could pick a model of your choice. Also, if it is a very specific need, you could go with a smaller model and fine-tune it to your specific need. So that's where the model selection also becomes important. And it is, as I mentioned earlier, like at the task level also, it's possible that you would like to mix and match, or you can say experiment with different models. But definitely to start with, we would go with like a more mature model, and then for cost and other considerations, we can slowly bring in different other models as we continuously consider the other enterprise requirements like privacy and compliance. And that's where the controlled or open source model becomes more reliable, where you can deploy it on the cloud of your choice and have complete control over it. Also, I mean, your system should have the capability to evaluate your models so that you're able to compare and decide which model is the best for your use case. Moving on. Finally, like as we said, like the knowledge context, this is another important aspect. So being able to set up your knowledge, whether it is wherever it is like lying on your database or maybe your document repository. So you would have to accordingly identify it and then identify the suitable RAG approach to connect to it so that you are able to augment your agent knowledge with this context. And then being also another important aspect is how you're chunking the data and setting up your RAG, because now you have like different options to ensure that your RAG is performing well enough. You can have a self-corrective RAG. which is improving and correcting, assessing its own performance, and then continuously improving. So that's where you have to optimize and validate your results and move towards a more accurate model overall. And finally, once you have all this in place, Scott, we can move to the next slide.
You got it.
Yeah, so finally, with all this in place, as we deploy our ecosystem, we have to ensure that it is a self-improving one, because as the data changes, as the user feedback is received, it should be able to improve. And improvement could be in the form of, say, collecting the data and fine-tuning your model further, or it could be fine-tuning your prompts. So again, depending on the use case, that would change, but then your overall ecosystem should factor all these aspects, so that it's like a futuristic approach, because definitely this thing is evolving and getting better day by day. So we have to go with the open and futuristic approach and not a closed design, so that even if you take to production, there is always the scope for improving. You can change models if a better model comes in tomorrow, a very specific model. So you should be able to monitor the performance. You should be able to collect user feedback. So, and of course, basic error handling is the need for any enterprise application. So with all this in place, you will be ready to take your agent into a enterprise workflow. And depending on the criticality of the agent, you would necessarily have to have like the monitoring, the human in the loop. So with all this in place, I would say today, this ecosystem is ready to be like seriously used in enterprises. So yeah, any thoughts from your side, Scott?
Yeah, no, I mean, these are all important steps. It may seem like a lot, and certainly it is a fair amount, right? But really, it's just steps you want to go through to make sure you're successful. And so not as bad as it might seem, but definitely these are steps you want to take. And I think if you follow those phases, I think you'll be successful. And like Abhilasha said, things are changing, just it almost seems daily. So it's just important to stay on top of what's going on out there as well. But no, I think you did a good job there. But yeah, these phases are very important to follow, in my opinion.
Sure. So now we will, so this is like a high level example of how you could depict a workflow. Now, we have taken an example of wealth management, where there is a customer query coming in, and the query could be related to any of these aspects. It could be a single stock analysis, it could be a portfolio analysis, it could be a general like IPO or fund analysis, it could be a general FAQ question, like a customer support question, or it could be a company research for that matter. So depending on the type of query, you would identify like what are the steps needed, what is the document, is there a need for unstructured to structured conversions, so that you have like maybe you have to make an API call to get the data for the stock, the indicators of the stock, or you want to make a search call to do more research about the company. So accordingly, you would like identify the different tasks here for the different steps and the different tools which are needed for each of these. So this is a way where we can actually visualize the flow which we are trying to implement. And today's demo is like one part of this overall flow. I'm sorry.
Bless you.
So yeah, maybe I'll share my screen now.
Sure. Yeah, that'd be good.
I'm sorry. So my screen is visible, right, Scott?
Let's see. I don't see your screen. Try again to share, Abhilasha.
I can see your screen, Abhilasha.
You can now?
Oh, you
Okay,
can? Okay.
good.
Oh, thank you. I'll just go back to this.
Yep, good. There we go.
Yeah, so maybe I'll just quickly. Yeah, so just to give you an idea of the stock analysis agent, which I'll be demoing right now. So the agent internally has been split up into sub agents where as you can see, like each of these nodes are actually performing some activity, like maybe fetching the indicator data. So if you have an idea of the stock market, you would so these are like different company shares, and people invest in them based on the performance of the company. And in order to like research about the performance of the company, you have different indicators which range from fundamental indicators. So this in order to make a like judgment, all this data is collected by the stock analyst, and then they would also check the latest news in the market, what is the sentiment going on, or anything related to the industry. So that is what we have tried to replicate in some proportion. And definitely, like I mean, this is a topic which can like evolve, and there can be multiple other things. But then to start with, the indicators, the market news, and then how this data is aggregated and used by the LLM to give a final recommendation. So that's where you can see like the different sources of the data, then the different agents interacting with each other. Then we have like a scoring agent which aggregates and finally gives the recommendation. And then we have an evaluation agent, which just it is another important aspect, because whenever we have the model making a decision or giving a recommendation, it's always better to do a cross check using the model like a self evaluator as well, or you can have a human in the loop. So in this case, we have used a self evaluator, which does, based on all the data which was provided to it, it just does a reassessment of whether the score generated and the recommendation generated is right or not. So yeah, so I'll just move on to the demo of the application. And this is built on using the agent tree ecosystem, which I explained. So we call it agent tree wealth here, and this is related to wealth management, where we have the stock analyzer. Now here you can actually give the stock of what you would like to analyze. So I'll start with entry. And once you click on analyze, so multiple agents, which we just saw, right? So those kick into action, and then they step by step, they collect the data and they give it on to the aggregation agent. So and then we have the portfolio here, where we can actually see our whatever stocks we have analyzed for how they have performed in the past. Basically the past history of that can be seen in the portfolio. So here you can see some past recommendations. So this is how the results come in, where you can actually like see the analysis. So this data is totally collected by the bot agent, making API calls, collecting the different indicators, and then the LLMs coming into picture, aggregating the data, applying some strategies. So there are certain strategies which we have applied, like the support and resistance analysis, or the so these are different strategies, and based on the strategy, the model gives the recommendation. So overall, then we provide a score. So the scoring is what the scoring agent comes up with, and it gives the reasoning also. So yeah, so let's go back and so that's the basic idea here, where you can actually automate and replicate. So here, yeah, so this is how you can see all the different details which were collected by the agent, and then finally the consolidated analysis. Also, like there is market data which is getting fetched, the news data. So for that, we are using the Tavily API, and that is a tool for this agent ecosystem. So that's how you can actually build your agents. And here, for this use case, we have used the land graph as the base because we wanted a more controlled flow where the agent is consolidating all this information step by step and aggregating it and then coming up with the recommendations as we saw in the architecture. But yeah, like depending on the use case, we can align it or use a different framework also. So
Great. Yeah, that's good, Alessia. I think just one quick note. I know we're at the bottom of the hour. If you have a question, we'll plan on just answering those questions quick. If you need to drop, that's okay. We're recording. We'll send out the recording and we'll send you. It'll contain the answers to those questions that are sitting out there. So sorry, Abhilasha, didn't mean to interrupt.
Yeah, so I'm done, Scott. So we can just move on to the questions then.
Okay. Sounds good. I'll just start at the start. Jeff
Right.
had a, oh yeah, go ahead, Anjali.
Yeah. So moving on to the Q&A session, please feel free to ask anything related to our discussion today, and we'll address your questions promptly. So Scott, we do have few questions here. So
Yep, for
firstly,
sure.
yeah. So related to our question about the use case, Jeff wrote here customer support, answering questions and making recommendations.
Definitely good use cases for sure.
Yeah, and another one, track and optimize inventory and ordering. So
Yep.
yeah.
Great use
And
cases.
so Wajid Jabir wants to ask, how can people who work in AI benefit from this? How is this going to affect the job market, and how can someone combat it and benefit from it?
I think this is a question, how's it going to affect the job market? I think this is a question that I've kind of had to ask throughout my career in technology, right? Even back in the factory automation days I was working, and a lot of folks are like, wow, how is this technology going to change the way we do our work? Is it going to take jobs? Is it going to do X, Y, Z? And I think what I have found in 30 something years is, yeah, there may be jobs that can be, that can be done better in this way. But the way I'm seeing the current technology is, it usually just enhances what we're doing. Right? These agents can do a lot, but they usually just they make the person's job, to me, a lot not easier, but just more efficient, and allow the person to really focus on, kind of where their strengths are anyway. So certainly it's a disruptive technology, that's for sure. But, again, I think that we just learn to use technology like we've done for many, many years, learn how to use it for our good, to make the jobs, more efficient, and get it so that the human themselves can actually focus on areas that maybe need a little more human touch, right? So I definitely think it'll impact the job market, but what I'm seeing right now, I think it impacts it in a good way, not necessarily something that we're going to see. We're seeing mass layoffs because of. I'm not going to say that there won't be jobs that go away because of it, but typically when one goes away, another's created in the process of that. And I don't really see that this will be too different than what we've seen in the past, right? So I think it's just a continuous innovation cycle that we're in as humans, as a country, as globally, for that matter. Abhilasha, any thoughts?
Yeah, absolutely, Scott. Like you have covered the, you can say, gist of it.
Yep.
So,
Yep. I have survived for 30
yeah.
something years with technology innovation. So you can do it for sure.
Yeah, absolutely.
Okay, next one.
Also, if we have any like example or any specific use case of each AI type.
Yeah, sure. Maybe I'll, like for example, let me start with simple reflex models. It's more like very simple use cases like automatic, if you want to respond to emails, automatic response, or allowing like some behavior of threshold, like based on some threshold, if you want to do something like an if-else condition. So if the threshold is met, then do something, right? So that becomes a simple use case. If the mail is spam, then just mark it spam, like if the subject is unrelated. Now, if you bring in the model-based use reflex agent, so there you would bring in some kind of decision making that the model is able to say optimize stock based on what is the current inventory. So that could be one decision. If you take it to the next level, like a goal-based agent, so that would be more like where there is a specific goal. So there, it's actually, that is where a real autonomous agent comes into play. Before that, it's more of just a decision making. But with a goal-based agent, you're actually giving a specific goal to your like your agent, and then it is taking the steps, it is making some decisions, and it is automatically moving on. So that's where the goal-based agent comes into picture. And with the goal-based, so an example of that could be like an advanced chatbot, which is able to make like ask you a counter question maybe, or give you responses based on the question you are asking from different sources, or maybe just a self-driving like a self-driving vehicle where it is an autonomous and it is doing a certain task. And yeah, if you compare like a GPS system is like a model which is actually giving you the like a very specific task of step-by-step navigation, right? But a self-driving vehicle is actually taking decisions and doing the behavior autonomously. And then if you associate the utility, that is where the recommendation. So if you're providing product recommendation or the stock recommendation, which we saw, so that is a utility-based agent. And finally, the last one was the multi-agent. So that's again like a bigger problem you're trying to solve. For example, say even the stock analysis example, where again you are breaking down into smaller tasks where each agent, so one agent is just doing the indicator analysis, one agent is applying the strategies, one agent is scoring. So that's where that could be an example of multi-agent ecosystem. Hope that answers the question.
Yeah. All right. So Matthew wants to ask, please tell me more about the strategy workshop.
So maybe that can be like, do you want to take that question here, or we can? So, okay, briefly, I would mention, so strategy workshop is specifically based on the domain of interest. We plan a like a half-day workshop where we showcase specific use cases for the domain, where we apply the agentry ecosystem, and then we have other accelerators to the domain and showcase those ready-to-use accelerators and how those could be applied to your enterprise. Additionally, we understand or maybe replicate or showcase the problem of the domain and how it can be solved using the Gen AI and the agent ecosystem. So that's in brief. But yeah, maybe Anjali, we can share the details of the URL and the documents for this.
Sure, Abhilasha. So, how are these code executors implemented?
Okay, maybe I'll take that. So again, depending on the type of framework you use, the implementation could vary a bit. But if I take the example of Autogen, so Autogen provides these compilers where you can like you can have either a Docker-based compilation or you can have a local environment compilation where you can actually compile and check if the code is correct and it is working. So that's where it becomes important, like specifically for use cases where you're generating code, right? So it's you would want to ensure that the code is like accurate and working fine, and that's where these things become useful. So similarly, like if it is LangGraph, then you can actually like LangChain provides certain tools which can be used to execute and compile the code and check. So there are different ways this can be done depending on the framework we go with.
All right. So, Ashish Bhatnagar wrote, could you show a reference architecture?
I think this was covered, so I believe this is the old question.
Yeah, and I think to add to that, I think we showed kind of a reference implementation of the architecture. I think any detail, you could probably look up one of the one of the frameworks as well. So LangChain or AutoGen, for example. I think we showed a reference, our agent tree implementation.
All right then. Emily Carr wants to ask, like, how do the agents manage cross-functional collaboration in complex organizations, especially where multiple departments have varying data access and performance matrices?
So maybe I'll start with it.
Sure.
So if it's a complex organization with multiple organizations and multiple departments interacting and having access to the data, so we would have to look at identifying the different agents which would be maybe associated with different department roles and performing the different tasks. And that's where like you would have like the role-based access defined for the agent, where the agent associated with the role would have access to a specific type of data, a specific type of knowledge repository. And accordingly, as part of the agent setup, you would have the associated performance metrics. Now, internally, if there is a requirement where the multi-agents are interacting, so that interaction point has to be defined in a way that you don't give away any unwanted data. It is a point-to-point communication of only what is needed. So that's where the 5-phase process which I mentioned, right? So you would have to define these aspects, and as part of the implementation, that can be taken care of, where you are having the memory segregated, because agent internally also the way if you define, you can have the agent interacting with the state, and you have only the related state for that agent. Like the entire state is not exposed to all the agents. It is like a specific state associated with the agent, which has only the data related to the agent. So accordingly, that can be the flow can be defined and maintained.
Yep.
All right.
Good.
So Mona wants to know how to integrate an e-commerce or module like order management can integrate to this agent.
You could use like a tool calling where you have, so definitely any external system, e-commerce or order management would have some APIs typically to interact with them, or the database access, depending on. So mostly it would be API access only, where you would have a structured like a tool API defined to interact with the external ecosystem by clearly defining the request response format of interaction, so that the model is able to replicate that behavior. You can do it by means of function calling and ensure that the correct input is going to the external system and you're getting the right output. So that's where the interaction is ensured to be controlled and in the correct format.
All right, the next one. How customizable are the AI models used within agent tree architecture? Can we fine-tune these models for highly specific tasks while maintaining cost efficiency?
Yeah, so absolutely, like as I showed in the architecture, so we have the model configuration piece, which is associated with the different agents, or you can also associate it with the task level. So that's where you can actually like have specific models for specific tasks in order to have that level of control and customizability. Because as you have rightly mentioned, like you would want to go for a very specific model to ensure that cost efficiency instead of going for a very like costly or high end model.
For sure.
So that can be totally controlled.
All right. So the next one is, not sure if this was asked earlier. How can we have agents to help with daily, weekly, repetitive finance tasks?
So it's like you could define those agents as co-pilots. Now, I mean, this is a very generic question. So basically, we'll have to identify the tasks, what we are talking about, and then accordingly define agents. So as we saw the wealth management flow, that is one of the finance tasks you can think of, right? So, like you identify the different aspects of what are the things you would want to do, what is the frequency at which that should be done, and then accordingly it can be automated. So whether you, for example, if you want to have a daily notification which analyzes all the stocks of your portfolio and gives you a daily recommendation of how the market is opening on that day, what is the sentiment, or suppose there's a quarterly company results which are coming in, so what is expected out of it. So a kind of recommendation could go daily, or there could be a consolidated one, you set it for weekly. So that could be configured as part of the notification setup of the agent, and you can have the repetitive behavior in your agent ecosystem.
Yeah.
All right, then. We have two more questions from Mona Nia. So let me just read them at once. How to use agent in microservices architecture, like order management module with AI agent. And the another one is, how will be the agent role in system integrations compared to API? How APIs can be agent enabled and reach to smart API.
Okay, how to use agent in microservices architecture? So basically, again, it's more about interacting with the API here, whether it is a order management module or any other external application. I already answered this, so you would like define that as a tool in your agent ecosystem, and through that tool, you will be able to interact with the module. Interact with the APIs and then replicate the behavior which you want to. So, and again, like for example, in the Llama agents, each agent itself is a microservice, the way it is structured. So that can be a service to service call, and you have that level of scalability to have as many as needed. The next one, how will the agent role in system integration compare to API? How APIs can be agent enabled and reach to smart API. I'm not sure if I got this question correctly, but if it is something to do with like if there are multiple systems and the agent needs to identify like which API to invoke, something like a smart API. So again, that would be a kind of intent classification, which your agent would have to do as a first step in order to decide what is expected behavior and then accordingly invoke the related API. So that would ensure a smart API kind of behavior. I hope I've answered your question if I got it right. Yeah, I think there's a last one. How we can make these AI agents working in a continuous work cycle instead of sending a stock signal as an input trigger, basically generating a continuous summary as soon as the user accesses our portal. So to speak, yeah, definitely. So it's more of a like, see, it's a customizable setup, how you want to have your agent behave, right? So it could be a behavior which is waiting for a user input, or it could be a dynamic behavior which is triggered as as I mentioned. So it could be a daily like a scheduled agent behavior. So automatically it uh, like kicks in and does the task and then sends a report to the user. So so those are all customizations which are possible to be done. So the agent can be working in the background, collecting all the details and sending you a summary. So yeah, that is totally possible. Also, the next question is, if we can use such AI agents to create an automated system to organize and manage our tasks at an enterprise production level, is that a use case that can be explored? Absolutely. So, like definitely, as we identify the different tasks we want to automate, we can define the agents accordingly, and wherever needed, depending on the criticality of the task, we can have a human in the loop to ensure that the agent is behaving in the expected manner. Or like in most cases, we could have, if there is a predictable result which can be evaluated, a self-evaluation layer also can suffice. So accordingly, the entire flow can be designed and implemented and in an enterprise environment. Yeah, so there are some more questions. Can we build these agents completely on open source, just like AI models and transfer learning? What will be the shortcomings if so? So yeah, you can do it. So instead of like if you want to go with the traditional AI models, so as like these are tools, right? So you can, as these are all customizable components. So it is up to us how we implement it. What is the like behavior we want to bring in there, and that can be embedded and defined in the application. And it can be completely open source. So it can be like AI models, or it can be open source LLM models, depending on what you want. Definitely, like the decision making capabilities or the interactiveness, for that you would need an LLM angle to it, definitely, right? So otherwise, if you just purely go with AI models, yeah. So again, it would depend on the use case, but that is one shortcoming I can think of, that the advantage which LLMs bring up, right? That interactivity or human-like interaction, that could be missing if we do without LLMs.
All right. Next up, we have a question again from Nirmit. How do we use AI agents for summarization and classification, topic modeling tasks, and minimize hallucination or incorrect classifications?
Yeah, so like again, this is a very specific use case.
Yep.
It can be detailed, and like bringing in the aspect of evaluation, combination of traditional classification and language model classification. We can bring in the control and minimize hallucination. But yeah, we can we can discuss and detail it further. But yeah, as a high level, that's what.
And I think got a couple more, then we'll have to wrap it out. I know there's one out there about cost, and I don't know that, Abhilasha, that we've seen several of these, but little different applications on each of them. I don't know if I can give an average cost, honestly, without knowing
So I
specifically
think
what has to be done.
it would be better if we can discuss one-to-one, understand the use case, and then
Yeah, got a lot of all, it all depends questions in there, right?
Right, yeah.
Okay. All right. Any others, Anjali?
Yeah, we do have a few more.
Okay.
So
maybe a couple more, then I think we're probably going to have to call it. So we can answer them, when we send out an email too, if there's not too many, if they're depending on how many there are.
Sure. So thank you so much, our incredible speakers, Scott and Abhilasha, for sharing their expertise today. And a huge thank you to all of you joining us. We hope you found the discussion insightful and inspiring. We look forward to seeing you in our next webinar. Stay tuned for the updates. Thank you.
Okay. Thank you.
Thank you.
Thank you, Abhilasha. Thank you.